Good afternoon. I'm Glenn Wallace, Technical Director from Wurth Elektronik. There's been a slight change to the advertised programme, so if you're expecting a masterclass on digital sensors, I do apologise. Our actual presenter from Wurth Elektronik has had to attend a family commitment, unfortunately at a funeral. So due to the short notice, we've actually changed the presentation. So if it's still of interest, this one will be on radio equipment directive. So basically looking at how to take a pre-approved radio module and implement that into a product. Okay. Just wait for everyone to settle down. Right. So when it comes to radio equipment, I do have to be a little bit careful. I know I've got one expert in the room at least. With radio products, you have various different conformities regarding where you're going to place your end product in the market. Examples would be CE marking, FCC, UKCA mark, as and when the UK government make up their mind when the actual transition period ends and actually is being implemented. So when it comes to radio equipment, we'll look at, once again, the radio equipment regulation for the UKCA and radio equipment directive. And then when you look through the actual definitions, here are the terms of what is radio equipment, what is radio communications, radio determination, and radio waves. But interestingly here, radio equipment, so an electrical or electronic product which intentionally emits or receives radio waves for the purpose of radio communications, radio determination. So when you take your pre-approved RF module, place it into a piece of equipment, that is in effect what you're now making the end product into, a piece of radio equipment. However, as I mentioned, pre-approved radio modules. What do we mean by pre-approved? Are they fully pre-approved? There is no definition of radio module in the Radio Equipment Directive. However, the notified body organisation, Redcar, have published a public TGN, so a technical guidance note, to assist industry, and that's both us as radio equipment module manufacturers and you as customers implementing those products. So TGN 01 defines what is a radio module. So within these are the actual definition extractions out of that particular document. And within here, we're highlighting that a radio module is something that's built into the final product. That the actual radio module is then intended for installation in that host product. So it's trying to define what is this radio module against what is radio equipment. So the essential requirements of the Radio Equipment Directive, this is a legal obligation. So in this case, Article 3, or in the Radio Equipment Regulations, Chapter 1, Clause 6. So 3.1 is with regard to the actual radio equipment is constructed to, one, make sure it's electrically safe. So the end user is in persons, and what's quite interesting, they also refer to domestic animals. I don't know of many directives that actually make reference to domestic animals, are actually protected as well as the property with regard to electrical safety, and once again references the low voltage directive. Another thing to note here when you're implementing a radio module into a radio product is that this particular directive then amends the lower voltage limit of the low voltage directive with no voltage limit applying, so basically from 0 volts DC. So there's a slight difference there. The other thing is then electromagnetic compatibility, making sure that your product does not interfere with intentional RF transmission services. These are all self-declaration. So if anyone is actually designing a product, one of the last things you do before placing that product onto the market is somebody signs off what they call a declaration of conformity, and this you can do by yourself. Then we get down to clause 3.2, the radio equipment shall be constructed so it effectively uses and supports the efficient use of the radio spectrum. We are now so entwined in our wireless environment. Is there infinite bandwidth? How many of us have all got mobile phones? And I shall see how many times they ring while I'm doing this very short presentation. But what we need to do here is actually protect that bandwidth. We can't have devices basically hogging a certain channel. So we need devices that can channel hop. So we allow multiple devices within a certain bandwidth. And this is what this particular clause is trying to set out there. Likewise, to avoid any harmful interference to that radio spectrum. Now, when you are doing your certification on the actual end product by embedding, say, an RF module or an RF chipset, if you use what we call harmonized standards, harmonized standard is something that is listed in the official journal. That's from a European perspective. If we're talking about UKCA mark, we can't call them harmonized standards, but we call them designated standards. These are standards that have actually been approved to meet these essential requirements. If you use a harmonized standard in full, you can then self-declare. If you can't use it in full, now it may be the fact that your end product has certain design constraints that doesn't allow you, maybe that there isn't a particular harmonized standard for the type of end product you're designing your pre-approved module into, then you may have to then use a notified body to do that final part of the approval. Or if no harmonized standard is available at all. So it could be that once again the pre-approved radio module has been tested or certified to a harmonized standard. As soon as you take that and embed it into your end product is what you're now certifying. If there is no harmonized standard, then this is where you then use the likes of a notified body. So what we're trying to say here is that you can't just assume that if a RF module is CE marked, you can just import it straight into a product and still maintain that CE mark. As a manufacturer, you've got to look at what the end product is actually doing with regard to its functionality, the environment that it's being used in, and make sure you meet the correct standards. We then come on to Article 3. This is a slightly old slide because I know things have changed a little bit. So 3.3a from memory has now been taken out and made into Article 3.4 with regard to common charges. So this is certainly within the Radio Equipment Directive. I've not seen this been updated yet with regard to the radio equipment regulations for the UKCA. So unfortunately with Brexit, I hate to use that word again, but we have what we call divergence. So a CE mark does not necessarily mean that it's fit for purpose in the UK market. So USB common charges, so the USB-C port is now covered under Article 3.4. A couple of other interesting changes that are coming in around about 2024, 2025 are with regard to misuse of the networks, in effect cyber security. So this is going to be an ongoing challenge, not only for us as module manufacturers, making sure that our module meets the cyber security requirements, but you as the end customer, making sure that the end product, the radio equipment, meets those cyber security requirements. How many people actually use RF modules in their products? Let's just do a quick hands up. One or two. Okay. So here we just have a very quick overview of the routes to compliance. So I've mentioned before Article 3.1 health and safety, Article 3.1b EMC. These we can self-declare. Article 3.2 is the real critical one because that's ensuring you have effective use of the RF spectrum. So if you use your harmonized standard in full, then you can self-declare. If not, then this is where you will typically use what we call this notified body. So integrating an RF module into a product. I have an example here of a Arduino board, and this one doesn't have any RF facility, so customers come along, they want to use, in this case, one of our Proteus 3 Wi-Fi modules. So how many of you agree with that nice little equation, CE plus CE equals CE? I've got one or two people not shaking their heads, so does everyone else agree that this is what happens? So I can take a CE marked unit, add another CE marked unit to it, and it's compliant. How many of you get involved in the actual compliance side of it? Testing, EMC testing, radio approvals, right. Is that really the case? Not normally. There is always an issue somewhere along the lines. It may get even more complex when we get things like the UKCA mark plus CE mark, because I say we may have this divergence. Where are we going with this? Well, what you can start to do is actually look at what, say for example, with the radio module manufacturer, what information are they providing with their radio module? So on the left-hand side, I've actually found the declaration conformity. It is publicly available for that particular Arduino unit. And we can see what they are basing their CE marking on. So in this case, they're basing it on the ROS directive, which is a requirement for CE marking. They're also basing it on low voltage directive, in this case EN 6950. Quite an old standard, soon to be replaced, or in transition, or finished. And then finally, they've also measured the EMF. So when it's EMF, that's actually measuring the electromagnetic fields radiating from that product with respect to being absorbed by the human body. Nowhere in there is actually anything with regard to EMC. So when I now take that particular product and I now place this RF module on top, does CE plus CE equal CE? In this case, no. So here's an example of our declaration conformity for our particular Proteus 3 module. And with regard to the standards, we've got our actual radio standard, EN 300-328. We've then got the EMC requirements, 301, 489, and the various two parts. 624479, and then 62368, which is now the new modern version of, or has now replaced EN 6950 with regard to low voltage. There is a mismatch between some of those standards, and this is where, once again, when you're looking at integrating a pre-approved module, you need to have a look at that documentation. You can't just take for fact that it's CE marked. So what other information may you need to consider? Well, as an RF module manufacturer, we also need to make you aware as the end customer of your obligations. Certainly, conformity assessment of the final product. Although the module, so when these modules are tested, they're normally tested on an eval board. So the actual certification itself is based on that eval board itself. A couple of little power supplies to power the unit. So it is classed as a sub-assembly. So when you integrate that sub-assembly onto your product, you now make your radio product. And we're here, as a manufacturer, we are giving you guidance that you do need to reassess your end product, your radio equipment product, against those applicable standards. So we're trying to be due diligent to assist you in that compliance. Other things that we need to also highlight are whether there are any critical accessories that you need to take into account to maintain its compliance. Antennas. We do get questions about, is it possible I can change my antenna with regard to my module? If, once again, the module has been tested and certified, from our perspective, our declaration conformity should be clear, as well as our instruction manual, as to what antenna has been used with that particular RF module. As soon as you change that antenna or the antenna path, in effect, you have a new product. You've invalidated any sort of certification or pre-testing that's been done on that module, and you would then have to re-evaluate the whole radio equipment. So yes, it is possible to change antennas, but you've got to be aware of, in effect, like the consequences and the ramifications of part of that approval. Changing of the assembly or of the actual antenna assembly or the antenna path. Certainly the antenna path becomes more critical if you are putting it into the American market. FCC are very, very specific that you use a particular layout with regard to the actual antenna matching. And once again, software versions. An RF module has been certified or has been declared to meet the essential requirements based on a certain revision of firmware. By changing the firmware, you may actually be able to change its operation. Hopefully, as a module manufacturer, we do not give you access to allow you to change the operating frequency, the channel allocations. If we do, there is a problem. because what you can now do is you can actually allocate a channel within a certain band. Unfortunately, that now does not meet the essential requirements of the Radio Equipment Directive, the Radio Equipment Regulations, because it's not effective use of the RF spectrum. So little changes to firmware can actually have an impact on your pre-approved radio module, either as a standalone device or once it's actually embedded into your end product. So when I actually take my pre-approved radio module and I embed it into my product, I am now combining two or more products, and one of those is radio communications, my RF module. So on this particular slide, what we're trying to highlight here is that, and it's really down to this last paragraph here, is that if the manufacturer of that combined equipment, so in this case the radio equipment, the final product, installs the radio module into the host, and the host is a non-radio product, in the equivalent assessment conditions. If you do that, and i.e. the host equivalent is the one used for the assessment of that particular radio product or that particular radio module, then no additional assessment is required. I've not come across any customers yet that can actually fulfill this requirement. And as I say, when most radio equipment module manufacturers are actually qualifying and certifying their modules, the actual module itself is too small, so it has to go on a daughter board or on a motherboard. That motherboard normally has additional power supplies. So what it's saying here is for you to actually carry that all across without any additional reassessment, you need that eval board. Well, that eval board could be twice the size of the product that you're designing the module into. So most of the time, I say customers are unable to meet that requirement. However, there is an ETSI, so European Telecommunications Standards. They have an engineering guidance note 203367 that actually gives you that particular guidance on how to apply the harmonized standards to meet Articles 3.1 and 3.2 when it comes to the combination of a host device, so a non-radio device, along with a piece of radio equipment, so a pre-approved radio module. That document in itself provides a wealth of information on helping you get to a compliant state by using these pre-approved modules. So time-wise, I can go down a discrete solution route. So I can look at a Nordic Semi, Sony Semiconductor, various other actual IC manufacturers. I can do all my hardware design, software development, application testing, and then normally the certification and listing comes at the last, as a last call. However, you do need to start considering from a compliance perspective a lot earlier in the design stage. So that's probably the longest duration to market route to be able to place your product onto the market. Second one, we then actually have the RF module. So just looking purely at hardware. So as I say, you can take a pre-approved module. The hardware design built around that particular module is more sort of power supply, more what the actual host device and its application, its performance. More time in developing the software. Once again, validation, application, testing, and then certification. And then certainly from our perspective as Wurth Elektronik, you can take our RF module along with our ProWare firmware and speed up the process. We can reduce it by about 50% in time compared to going down the discrete route. This is why we find most customers using pre-approved modules for the speed of access of getting the product to market. So good practices for RF module integration. Now I've mentioned, okay, you can take a pre-approved RF module. Firstly, they do need a very clean power supply. Why do I say a clean power supply? Once again, you're trying to replicate what we've had on our eval board that the actual module's been sat on while we've done our approval testing. Examples here would be of our Magic module series. These are all CISPA 32 compliant, and these have output ripple voltage of somewhere between 6 to 10 millivolts. So you're looking at very, very low ripple voltage to give you low EMI. And this is what typically the RF module is looking for. Yes, you can also do that with an LDO, but without the same high level of efficiency. Next, filtering. Filtering capacitors we typically recommend on the power lines. Once again, you'll see this in module manufacturers' data sheets and user manuals. The thing with an RF module is that when you're certifying it really across its operating temperature range. That may be from -40 to +85, could be from 0 to 70 degrees. But what do we actually certify? When we're actually doing the testing, what temperature is it? I guess roughly what we're sitting in at the moment, sort of 20, 25 degrees. However, certain components within your host product, as well as the radio module itself, are temperature dependent. Example here will be what seems to be quite simple, multi-layer ceramic capacitors. So how many of you are actual electronics design engineers? Hands up. How many of you actually take into account the DC bias effect when designing in multi-layer ceramic capacitors? Not as many hands go up. How many of you take into account the aging effect on multi-layer ceramic capacitors? Okay. How many of you take into account the temperature effect? So if you take into account the temperature effect, so nobody here is using X7Rs, X5Rs. You're paying the extra money in using MP0s. So I've got a few nods. Good. Okay. So once again, what you've got to bear in mind when you're talking about an RF module is that you want to make sure that any filtering that you're going to implement on that is going to be stable across that particular temperature range. So all we're trying to highlight here is the variance between MP0, which is the yellow line here, which is, because it's a class 1 material, there is no effect with regard to temperature, versus an X7R that will vary in capacitance value with regard to temperature. So once again, this can have an impact, not necessarily from a conformity perspective, but in a real world application. You might find that a customer starts complaining of potential issues, maybe due to higher or lower temperature, and that's because, once again, the capacitance value is varying. You've based all your calculations around a certain capacitance value, and that can cause problems. So once again, all we're trying to do is a little bit of a hint and a tip here that when you're using a pre-approved module, it's worth paying that little bit extra and going for those non-temperature dependent multi-layer ceramic capacitors. Likewise, ESD protection. RF modules are quite sensitive devices. It may be that your product has accessible pins, and therefore you may want to actually provide a level of ESD protection, so things like TVS diodes. Another thing, if you're using an antenna port, so maybe the actual pre-approved module has an inbuilt RF antenna, maybe it has a 50 ohm coax, which enables you to remove the actual antenna. So if the end user can actually remove the antenna, there's a potential there for an ESD discharge. So once again, the antenna ports are very, very sensitive, so you may need to consider ESD protection, in which case you also now need to take into account the level of channel-to-channel capacitance. Capacitance at high frequencies will lead to insertion loss, and that's what we're showing here as an example of a standard TVS diode. And so certain manufacturers, we being one of them, no pun intended on that one, we have femtofarad capacitors with very low insertion loss up to around about sort of 8 gigahertz in frequency. So these can be used on your antenna port for protection. Another way of reducing ESD, not as effective, and once again this comes out of our application notes and user manuals for our modules, is the introduction of a air core. In fact, you're just putting a high level of inductance in there to the ESD pulse to in effect slow it up from going into the actual product. So it's not as effective as an active ESD protection device. Filtering of the I/O lines. Now the RF module itself is an intentional transmitter. It could be transmitting, let's say, 868 megahertz, 2.4 gigs, radiating off the antenna. That intentional signal could then recouple back into your actual product. By coupling back into your product, typically through capacitive coupling, it may now feed back into the module, and you now get an instability in the actual RF circuit. So when it comes to I/O lines, there are certain products. Once again, we have a certain common mode choke. This one's a ceramic common mode filter that actually blocks. It's actually designed to be high insertion loss at 2.4 gigahertz. This you can now implement on, say, the UART lines, the SPI lines, to protect the data, but to stop the actual intentional radiated signal off the antenna recoupling back into the RF circuit. So once again, we've seen problems with customers implementing, say, pre-approved modules and not taking this into account. PCB layout, ground planes. We actually had a customer quite recently who didn't quite listen to the advice. What we're showing here as good practice is the actual positioning of the actual IC. So we can actually see here the radio module, and the yellow here is the actual ground plane. So we can see that the actual ground plane has been stripped back, and here's the actual antenna. So these are what we class as good design requirements with regard to layout. And then poor examples here. And so what we're actually seeing here is that this will actually disturb the radio antenna pattern. You're actually forming, using the actual ground plane, a second plate. So if you imagine the antenna is one plate of a capacitor, and you imagine the ground plane is the second plate of a capacitor, you've now got capacitive coupling. The antenna is generating electric field, and so you're actually now going to be drawing RF current back into the ground plane and shorting it out. This will have an impact, once again, on its transmission and reception distance. So follow the advice in the RF module manufacturer's application note or manual with regard to layout. But this is a typical guide on here. Antenna matching. So when it comes to antennas, certainly with external antennas, you may need to take into account additional antenna matching. So although the module itself, they may give you some guidance on additional components, be it inductors, RF capacitors, that you can now inbuild into your actual circuit with regard to matching. The actual antenna track between the module itself and the actual antenna should be as short as possible. By extending that track, you're almost, in effect, extending the antenna. If you actually extend it too far on the PCB, the actual PCB trace now starts to act as the antenna. You now cause yourself an EMI problem. That in itself can now cause more issues further down the line to resolve, normally resulting in more decoupling capacitors. Downside of that is you're now diverting the actual energy that you want from your transmitter, and then you're attenuating it. So when it comes to antenna matching, most of our modules already have inbuilt antennas. Those modules that don't, we offer a antenna matching service for our customers. Not everyone has that facility within their own lab, and therefore we offer this particular service. We also offer a guidance when it comes to custom firmware. As I mentioned before, if you do change the firmware, it can have an impact on the actual approval of the radio module. We offer this as a service where we can do custom firmware, and then we can do some very quick validation measurements to make sure it hasn't actually affected the pre-approved certification that we have on our RF modules. I'll just be very quick because I've been told I'm almost out of time. So as a very quick case study, if you've actually been to our exhibition stand, we do have an example here of what we call tennis ball, where we've actually taken one of our pre-approved modules, put it onto an eval board, and gone through the same pain as what you do as a customer when it comes to approvals. We've gone through all the EMC testing, radio approvals testing that is required. So it's obviously there's a product demonstration as well. We've got as much of our products on there. So power supply, RF module, in this case the Proteus 3, LEDs, we've got sensors on there, pressure, so we've got 3-axis, humidity, temperature sensors, etc. And then just very quickly highlighting what I've just spoken about is the same principles. We've gone through and ensured that the input filter had sufficient amount of suppression with regard to EMI, and reducing any of the ripple noise from the power supply. And by doing that, we use things like an online tool called Red Expert for designing in the capacitors, looking at actual capacitance value, looking at the inductors to make sure we have had the correct amount of suppression, and in which case we're typically aiming for 40 dBs per decade to make sure that we can keep the actual module compliant, make sure no noise is able to get into the module, or once again, noise to get back out. So on this particular slide, we're just giving a very quick overview of the actual process that we went through, identifying the actual via risk assessment of the product, what are the applicable directives, the route that we needed to take. So we wanted to take self-declaration, so we're going to use harmonized standards. We've identified what they are. Once again, very helpful. I've been able to use the pre-approved module from Wurth Elektronik as our harmonized standard route. We've then done additional testing to make sure we can still meet some of those essential requirements. We've documented that in our technical file. From that, we can then issue out our declaration conformity, and I can then place a UKCA mark or CE mark, once again subject to what market we're placing the product into. So that's the plan of action. And here is just an example of using the typical test that would be applied to a radio product. Now, if I've designed that radio product from scratch and I've used it with discrete components, I would need to meet all these particular clauses to meet those essential requirements. Because I'm using a pre-approved module, out of these sort of 15 tests, we've only had to reassess 2 of those. So the speed of access to the market is a lot quicker by using, say, these pre-approved modules, provided that the module manufacturer has done their testing due diligently and used the correct harmonized standards. Once again, you should be able to identify that from the DOC. So that was the radio approval side, and so that covers clause 3.2. This is clause 3.1b, EMC. Once again, out of 14 different tests, we've only actually had to repeat 4 of those particular tests. So it's once again just highlighting the benefit of using a good quality pre-approved radio module and the speed of access to market. Bit of a whirlwind tour, but thank you very much for your time. I guess any questions?
Just want to know if design files are available for that tennis ball example with schematics.
You're not the first person to ask. Yes, but we just need to have an NDA in place with you. I've stunned them into silence. Oh.
Would you be able to elaborate more on how can we validate that the harmonized standards apply to our product, and how we can tell that they're not, and we can't apply harmonized standard and we have to go to the other process?
So really, when you're developing your actual end product, and once I say the module itself will be tested to a certain standard, or should be certified to a certain standard to say it meets the essential requirements. So if an RF module doesn't have CE marking on it, FCC marking, the manufacturer may have done some form of testing, or they may have done nothing. But once again, if somebody's putting a mark on it, they're saying it complies. So it gives you at least some form of due diligence in that sense. So you should be able to take that information from the customer. However, that particular RF module, once you build it into your end product, you may be building, say, test and measurement equipment. But as soon as you put that RF module into it, it now not only is test and measurement, so you need to be able to assess that by itself, say for EMC, low voltage, but you've also then got to assess the radio side of that particular product. So, and this is why when we say, for example, with the tennis, with what we call the tennis ball, is in effect, it's almost like test and measurement because it's got various different sensors on there. So safety-wise, we can use that as the basis, but we still need to validate and make sure that we meet the radio side of the actual conformity. Because we haven't actually changed anything on the module, that particular standard still holds. Now, if for example the module is more of a software-defined radio, so I can play around with some of the frequencies, channel allocation, etc. It may be that takes it out of one particular harmonized standard and places it into a different type of harmonized standard. But when you're starting your design process, you need to start identifying these at the start and not at the end of the process. If you leave it too late in the design cycle, you will run into more and more problems. So you really need to identify what your end product is, the type of radio technology that you want to use to make sure that the correct harmonized standards are being applied, if they are available.
Thank you.
You mentioned that firmware is a critical part of the certification. What happens if there's a security flaw or a bug that's found?
One, as a module manufacturer, would have to make sure, well, I guess there's two parts to that question. One, as and when the cybersecurity is coming into effect, module manufacturers need to make sure that shouldn't happen in the first place. But in the current stance, where I guess it's not in place yet, the module manufacturer would still have to then, I guess, demonstrate as part of the compliance to make sure that whatever firmware changes they've implemented does not have an impact on the fundamental operation, once again, with regard to the radio side. That it's not able to change its operating frequency. That may be hardware defined. Once again, maybe once again, you're not able to align to a certain channel. So the manufacturer would really need to document that and hopefully issue out perhaps a product change notification to the customers to actually say, look, we've identified this as a problem. These are the changes that we've made. This is now the new firmware revision. So you can now take that documentation and put that into your technical documentation. That's now given you that level of due diligence once again. So this is where trying to work in partnership with your supplier, your module manufacturer, is a benefit.
Thank you.